it stops working again.
All right. Oh, that's not what I wanted to Can you get the lights for me, please? All right, so we're going to talk a little bit about area to start. How do you find the area of a rectangle? Length times width. So notice they gave me the area. Does everybody see this representation right here? They also gave me the width. So what am I going to have to try and find? The length. Now, I would be multiplying whatever this is down here times that, correct? And whatever I get, it should be equal to this, correct? Because of the numbers that are in here, and because of that number that I know, I should be able to eliminate two of these answers. Why F and J? Because I'm covering it. Well, I just drew the lines through it. Oh, my hand's just sitting here. Why can I get rid of F and J? Okay, because what is 5 times 3? Do I see any 15s in here? No. So it's either got to be x plus 6 or x minus 6. Which one? It's got to be the minus, because negative 6 times a positive 3 would be that negative 18. Does that make sense to everybody? All right. Let's go over here. Now, I hope that you guys can tell me how to find the area of a triangle. Correct. It's 1/2 base times height. Thank you. Does the 1/2 ever change? It doesn't. What is the height of this triangle? Or excuse me, the base of this triangle. And then the other one? So this is a multiplication problem, isn't it? When we multiply, what do we do with the coefficients? What do we do with these coefficients? Which means I'm multiplying them. What's 1/2 times 2? And then what do we do with these? Logan, that's where you were right. What am I going to do with these h's? Add them. So this will be 1h to the what power? Good. And what does it tell me my area is supposed to be? So I'm going to set this equal to 5h, and I have to solve this. Okay. Now, this is the type of equation we learned how to solve yesterday. Do you see how there's an h squared and an h? Guys, you cannot just isolate this because it's two different types of variables. So yesterday we talked about setting this equal to 0. How do I set this equal to 0? Minus the 5h. Do you agree that h squared and h do not go together? So I'm writing them separately. Now I have to factor it. So can you take out a GCF of what? Thank you. Yes, you could take out an h, meaning I'm dividing all of these by h. What's left? Is everybody all right there? So now that this is factored, now I'm going to set the factors equal to 0. Either h can be 0 or h minus 5 can be 0. Now, this one's already done for you. H is just 0. How about over here? H is positive 5 because I would add the 5 over, and this would be a positive 5. Now, can I have a height of 0 on a triangle? I cannot. But what was the representation for my height up there? On that triangle, it's 2h, correct? And what is my h? So what is that going to be? 10. Because look here for me, Dylan. See how that says 2h? Right here? My h is 5, so it will be 10. Honestly, Dylan, when I did this fourth period, I chose B right off the bat. And I had to go back and say, no, wait, there's 2 times h, which makes it 10. Questions for me on the warm-up, folks? Okay. How many of you feel like you're good at doing patterns? If you know the pattern, you could do it. Great. Today's your day. Today is all about a pattern. I'm going to show you the pattern that happens on these problems, and as long as you can recreate that pattern, you're going to be just fine. Okay? When we factor, the first thing I've told you to always look for is a what? No, what's the first thing we do with factoring? Yes? What did I call them when we took something out by dividing? This problem right here, we factored it by dividing out an h, correct? And then we put this h out front, didn't we? What is that called? Yeah? No. I ask you, what can I take out of both terms, right? What's that called? What kind of a factor? A greatest common factor, which is a GCF. That's the first way I taught you how to factor. Take out a GCF. Then on that same day, we factored 4 terms. And how do I factor 4 terms? Grouping. I put parentheses around them, 2 by 2, right? It's called grouping. Today, I'm going to teach you how to do things that have 3 terms. Anytime that you have 3 terms and you want to factor it, you're going to do a binomial times a binomial. Do you agree that in this box down here below, you see a bunch of binomials times binomials? Okay, now I'll tell you, you're going to need to write small in this box. And I'm going to tell you that I'm going to do one from each side, and then we're just going to give you the rest of the answers. So you can see the pattern, okay? And once you see the pattern, it should, please stop. It should be pretty recognizable to you, okay? So here we go. How would I multiply this? How did I teach you to multiply this? Split them in half and then distribute. Okay, so it'll be x times x plus 4 plus 3 times x plus 4. Again, I suggest you write small. All right, so now let's distribute. What is x times x? What is x times 4? What is 3 times x? And what is 3 times 4? So then the middle 2 terms go together. And what do you get in the middle, guys? No, I don't. I want you to tell me what I get in the middle. Guys, what do I get in the middle if I add them together? What? 4x and 3x is 7x. Don't just leave it x. 4 plus 3 is 7. Right here? X? I don't know. Derek, are you okay on just leaving that just an x and not an x squared? Okay. And then, okay. This is plus 12 then. Is everybody all right with how we got that? And if you needed to, you could do that for all of these, correct? Okay, but I know the pattern in my head, so I'm going to show it to you and see if you can recognize what the pattern is. Here we go. This one will be d squared plus 11d plus 24. This one will be x squared minus 8x plus 12. And this one will be w squared minus 11w plus 28. Which number is multiplying 6 and 2? Do you agree that these 2 numbers added make this number, and these 2 numbers multiplied make that number? Do you agree that these 2 numbers added make that number, and these 2 numbers multiplied make that number? Now, you wouldn't have wanted the shortcut because I didn't give you these. I gave you these, and you had to do these. Now that we're working backwards, you have to have the shortcut. Fair enough? Guys, the whole goal in this lesson is for me to give you these trinomials and you give me the parentheses. That's what factoring means, isn't it? Give me the multiplication problem. Okay, so here's what I want you to recognize. I'm looking at these -7, this -4 down here. If I add them together, I still get a negative, don't I? But if I multiply them, it becomes positive. Agreed? Okay, so here's what I want you to write down here in this box. This is going to be describing the pattern. Okay. If you have a sum of the constant, that's going to mean the same symbols. So go ahead and write that, and I'll show you what it means. And then the second one is going to be you need factors of the constant to add to the middle. Factors of the constant to add to the middle. No. Once we get all this written, I'm going to show you the pattern one more time, and then we'll move over to the other column. Are you ready? Yes or no? Okay. Do you agree that this 12 is my constant? Constant means a number without the variable, right? I need factors of 12 that will add to 7, 3, and 4. Does that make sense? I need, what's my constant here? What are factors of 24 that will add to 11? You agree? What's my constant here? I need factors of 12 that will add to 8. 6 and 2, correct? They multiply to 12, but they add to 8. Agreed? What's my constant here? Factors of 28 that will add to 11. Do you see the pattern? Yes? Now, I want you to understand that all of these symbols on this constant, they're all pluses, aren't they? Yes, they are. And then all of these symbols over here, no. They're both the same. See, plus, 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 minus, 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 minus. Because a positive times a positive is a, come on, a positive times a positive is a positive, and a negative times a negative is a, so if you have the sum, right here, the sum of the constant, you have to have the same symbols, meaning both plus or both minus. Fair enough? Ready to move on to the other pattern? Okay, so let's do the first one together, and then I'll give you the rest of it. Chop it in half. So I have x times x plus 5 minus 3 times x plus 5. This gives me x squared plus 5x minus 3x minus 15. How we doing, guys? Good? So then what do I get in the middle? 2, right? All right, so let me show you the rest of them. This next one, you guys want me to give you a second? Are we okay? You're good? Okay, the next one is d squared minus 7d minus 18. Then I have x squared minus 2x minus 24. And then I have y squared plus 13y minus 48. So what's the pattern this time? Now it's subtraction. So do you agree that if I subtract these two numbers, I get this number? Do you agree if I subtract these two numbers, I get that number? Do you agree that if I subtract these, I get this? And if these, I get this? Yeah. But this time, my constant over here, what's the symbol on this? It's negative this time. It's subtraction of that constant, isn't it? What's the fancy word that means subtraction? Difference. So, if you have a difference of the constant, what do you notice about the symbols in the binomials? Are they the same like we had on the other column? They are. What word sounds like difference? Different. Difference of the constant means different symbols. And this time, instead of adding to the middle, we want to subtract to the middle. You want factors of the constant that subtract to the middle. So if we can keep up with this pattern, we're going to be just fine. You got to know when to add, you got to know when to subtract. What's that? Yeah, Tyler and Sarah too. It's all right. We'll get it. We're going to be doing this for a long time. Long time. All right, so do you see your trinomials down there? How many terms do you have in a trinomial? 3. Now, of course, we had this as our first step, right? If you look at number 1, is there a GCF that I can take out of all of those? Besides a 1? No. So if it's 3 terms, I know automatically I need to make a binomial times a binomial. Now, the easy part to this is, how am I going to make n squared? Not n plus n. So this will be an n, and this will be an n, because n times n is n squared. Is everybody all right there? Now, this whole problem hinges around the fact that my constant is being added. Do you guys all see how that's a plus sign? So I need factors of 24 that add to 11. No. Factors of 24. Factors of 24. Do you agree that 8 times 3 is 24? Yes. Do they also add to 11? They do. So I'm going to put an 8 and a 3 in here. So you looking at me like you got no idea what's going on has got to change here, folks. Either you know that 3 times 8 is 24 and 3 plus 8 is 11, or you don't. That's okay? You remember when I told you had to know your multiplication facts? This is why right here. Now, because this was adding, that tells me about my symbols in here. They either have to be plus plus or minus minus. But if I have a plus 11 in the middle, what do they need to be? They both need to be plus. Now, that is your answer. We're done. But I want to show you why this works. Are you ready? Okay, here's where you're done writing. I need your eyes. What is n times n? N squared. What is n times a positive 3? What is 8 times n? And what is 8 times 3? Do you agree if I put these two things together, it's the same as the original, which is exactly what we want? Is that okay? Let's try another one. Do you have a GCF in this problem? You don't, but it's a trinomial, so I'm going to make a binomial times a binomial. How am I going to make m squared? M times m. Now, this whole problem hinges around the fact that this constant of 30 is being added. Hold on a second. I need factors of 30 that will add to 11. 6 and 5. Does everybody agree that 6 times 5 is 30 and 6 plus 5 is 11? Yes. It does not matter the order in which you write those in there, folks. Now, if I have this plus 30 on the end, that tells me my symbols have to be the same. Hold on. This symbol right here tells me the symbols have to be the same. This symbol right here tells me what they need to be. They both need to be negatives. Let me show you how this works. What is m times m? What is m times negative 5? What is negative 6 times m? And what is negative 6 times negative 5? Do you agree if I put these two things together, I get the original problem? It works, right? That's the whole goal here. Fair enough? If you know the pattern, it's okay. Okay, we're going to come back to these. I want to keep, do you guys see how these both are pluses on the end? And these both are minuses on the end? I want to do a couple more with pluses, so we're good with that pattern, okay? So let's do a number 5. But what's up with number 5? It's backwards. Remember, standard form goes from highest power to lowest power, so you just need to rewrite it. Now, it's a trinomial. Do you have a GCF? You don't, so I'm going to make 2 binomials. How am I going to make that y squared? Now, my whole problem is around the fact that that's a plus 40. So I need factors of 40 that will add to 14. 9 times 5 is not 40. 4 and 10. Is 4 times 10 40? Yes. Is 4 plus 10 14? Yes. How you doing, Luke? Now, if this says a plus 40, that means my symbols have to be the same. And they both have to be adding, addition, like this. Again, let me show you why this works. What is y times y? What is y times 10? What is 4 times y? And what is 4 times 10? Do you agree if I put those together, I get the original problem? Yeah. Yeah. Okay, let's do the one right next to it, number 6. It's in the right order this time, right? Trinomial. It has no GCF, so I'm going to do a binomial times a binomial. What are my binomials going to start with? P and P. Now, folks, you all see this plus sign on the 18. I need factors of 8. Oh, I don't want that. Hold on a second. I need factors of 18 that add to 11. 9 and 2. Not the time to doodle and zone off on me, guys. Come on now. If I'm adding to 18, that means my symbols have to be the same. And they both have to be minus or subtraction. Can you find me another one that has a plus a constant? Number 9, he says. Yep, number 9 will work. Let's make my 2 binomials. What am I going to start them with? And this says plus 3. So I need factors of 3 that will add to 4. 3. Okay, I got to have 2 numbers, right? 3 and 1. Do you agree that 3 times 1 is 3? And 3 plus 1 is 4. Now, if this is plus, that means the symbols have to be the same. And what are they going to be? Addition. Let's do the one right next to it. What's got to happen first? Got to put it in order. So I have t squared minus 9t plus 8. Give me 2 binomials. Starting with t, I have a plus sign on my constant. I need factors of 8 that will add to 9. And they both have to be the same. And they both have to be subtraction. Okay, we're going to do one more of these, and we're going to go to the minus ones, okay? Yeah. Number 13, please. It's in the right order. What are we going to start these with? D's. You see the plus sign on the constant. I need factors of 6 that will add to 5. And if we are adding, that means they have to be the same, and they both have to be plus. Awesome. Let's try some subtracting ones now. Okay, let's go back to the front. Now, when we were adding, that means the symbols had to be the same, correct? But when we're subtracting, the symbols are going to have to be different. Here we go. Binomials. Starting with z. Does everybody see the minus on my constant? I need factors of 4 that will subtract to 3. 1 and 4. Now, correct. Now, we just said if there's subtraction, they have to be different, correct? But how do I know whether to put a plus and then a minus? Hold on. Listen, I'm going to tell you. Okay, does everybody see the plus on the 3? Yeah. Whichever one is bigger has to get the plus. The 4 is bigger than the 1, agreed? So that has to get the plus, and then the other one gets the minus. The bigger one always wins, whatever the middle symbol is. Okay, let's try number 4. 2 binomials, please. Starting with P. Everybody see the minus sign on that 12? So that means I need factors of 12 that will subtract to 1. 12. These things have to multiply to 12, folks. That's right, but it won't subtract to 1. Give me some numbers that multiply to 12. You already told me 12 and 1. 6 and 2, do those subtract to 1? No. 3 and 4, do those subtract to 1? Yes, they do. So we have 3 and 4. Now, because of that subtraction sign, I know my symbols have to be different. The bigger one has to be plus because of that plus right there. So my 4 is the plus and my 3 is the minus. It's a pattern. Listen, we're going to do it a lot, so we'll get a lot of practice on it. It'll be okay. Let's go to number 7. What am I starting with? Does everybody see the minus on the 28? So I need factors of 28 that will subtract to 3. What numbers that multiply to 28 will also subtract to 3? 4 and 7, 7 and 4. Now, we know because we're subtracting, symbols have to be different. The bigger one has to be minus. The 7 is the bigger one, so that's where the minus is. Number 8 starts with, you all see the minus on the 14, so I need factors of 14 that will subtract to 5. 7 and 2. If we're subtracting, the symbols have to be different. And the bigger one has to be subtraction. Whatever's in the middle goes with the bigger number. Okay. We all good here? 11 then 12, yep. Okay, give me my 2 binomials. Z's. You all see the minus on the 5. I need factors of 5 that will subtract to 4. Correct. Now, if we're subtracting, the symbols have to be different, and the bigger one has to be plus. You see how it's a pattern? Now, the numbers change, obviously, but it's a pattern. All right, let's go to 12. We're going to start with R and R. Hold on one second. You are correct. Everybody see that minus sign on there, right? So I need factors of 8 that will subtract to 2, and he's telling me 4 and 2. Symbols have to be different, and the bigger one has to be minus. Doing great. Let's go to 15, please. What's up with 15? It's backwards, so we're going to go c squared minus c minus 6. Starting with, you see the minus sign on the 6. I need factors of 6 that will subtract to 1. 2 and 3. We need different symbols, and the bigger one has to be, it's minus. See how that's a minus C right there? I didn't. It was a minus. Look, he's agreeing with me. This c squared is positive. That c is negative, and that's okay. That's okay. You thought he was agreeing with you. Okay. 16 over here. What are we going to start this one with? You see the minus sign here. I need factors of 15 that subtract to 2. Symbols will need to be different because of the subtraction sign. And my bigger one needs to be plus. Do you guys understand that whether it's the same or different has nothing to do with this guy right here, right? Nothing to do with that. It is all on that highlighted symbol. Maybe. Let's get rid of that. Do I have another line? Oh, I don't. I don't? Okay, 14 it is, and then we'll be done. Sorry. If If you had been in fourth period, you would have got extra credit. They didn't get close to this. What are we starting with? Now I got 2 issues with this problem. Yeah, that first of all, it should be an indication to you. Now, if we look at this, see that plus sign, right? So doesn't that mean I need factors of 5 that will add to 3? The only way to get factors of 5 is 5 times 1, agreed? Is there any other factors for that? And they definitely do not add to 3, agree? And I would have to get a negative, but I still can't make negative 3, can I? No, we call this thing prime. We call this thing prime because there are no numbers that fit the description or the pattern that I need. Now, I'll tell you, you got none of those on your homework, so don't try and write prime 7 times. None of them are prime, okay? Yeah, I think you only got 7 homework problems. Okay, so your homework is this right here, page 507. Delete this. Yep, 12 through 19. These are 12 through 9, the numbers, and just in case I'm going to go over them with you on Monday when I see you. So is it 8 problems? 8 problems. Okay, folks, I hope you have a good weekend, and we'll see you on Monday.